Page 352, we're doing 1 through 12. Starting on 5 is graphing. No, we're just doing that. On number 1 through 4, they're really quick. It just says evaluate. So what does that mean? Solve it. So it says on number 1, x is 5, y equals 1/2 to the x. So it's y equals 1/2 to the 5th. You guys know how to do this without a calculator?
2.5? Nope. Wouldn't it just be 2?
Well, it's just 1/2 times 1/2 times 1/2 times 1.
Okay.
So what's 1 times 1 times 1 times 1 times 1? 1. What's 2 times 2
4
times 2?
8,
2.
16,
2.
1/32.
I said, do you know how to do it without a calculator?
I don't.
We just did it.
Wow.
Okay, number 3. 3 times 4 to the x when x is 3. So y equals 3. 4 to the 3rd.
48.
No.
It's all 48.
Okay, remember exponents.
64.
Exponents come before multiplication. 4 times 4 is 16. 16 times 4 is 64. 64 times 3 is
192.
Yeah, 192.
We did it. I'm so smart sometimes, occasionally.
Well, what are we gonna do when we
Happens
have to find the
sometimes.
x? Like on the next one?
You don't find the x, you find the y. Huh? It says 192.
Oh, I get it. You plug in the.
Yeah, they're giving us, so yesterday we kind of made up our own x values and plugged them in. The difference is what kind of functions we are graphing. The difference is that the exponents are the variables. So that we haven't seen anything quite like this on the graphs. But it's not a big deal. Just plug stuff in and see what you get. So on number 5, we got y equals 3 to the x. Okay, this is going to be a graphing problem. But we also have to fill out the table basically. You can do all of that on graph paper, or you can like split it up.
I like to split it up.
This person's filled in the table.
Okay,
10.
well just do it. You can see if they got it right. Well,
So y was the first one? Should be 9.
okay, if I plug in -2, I bet you guys forgot.
It's 1/9, right?
Okay, yeah, 3 squared is 9. 3 times 3, but what is 3 to the negative?
1/9.
It's 1/9. Yes. If you plug 1/9 in if you plug it in your calculator, it would give you 0.1111, but that's just 1/9.
That mean on the graph it's gonna be just like a
Your
little bit
calculator
less
is in
time.
fraction mode.
Yeah.
Okay, still number 5, but next one. -1, what's 3 to the -1?
-3.
No,
1/3.
1/3. Okay, a negative in the exponent does not make the value negative. It just flips, makes it a reciprocal. Instead of 3, it's 1/3. What's 3 to the 0? What's anything to the 0 is 1. What's 3 to the first?
3.
What's 3 to the second? 9. Okay, so there is a kind of a symmetry. 1/9, 9, 1/3, 3. Okay, when you go to graph that, it's really everything's happening on the top of the graph, so you might put your x-axis down low, because everything's happening high. We got to go up to +9 on this one. So put your x-axis low. See if I can move mine.
But
There
I
we go.
don't. It needs to all be equal. Let's see.
Got some OCD tendencies.
Yes.
So 1, 2, 3, 4, 5, 6, 7, 8, 9. I can count. Aren't you guys impressed?
Oh my
The
God.
math
I
teacher
hope you
count?
Or a math teacher.
I'm a pretty good counter.
Good job,
You
math
can
teacher.
count on that?
Will. You should be ashamed of yourself. Okay, if I plug in, where's -2 1/9 at?
-2. 1/9 is like right over there.
Okay, yeah, -2's right there. 1/9 just off the line. I don't know.
It's barely off.
This the smart board's not calibrated enough for me to do this well.
My paper is. Ha.
Okay, that table's just condemned today. -1, 1/3. So we go back 1 and
Just
up
under half,
1/3.
like a little under
Just
half.
a little
A
bit,
bit higher.
little bit higher than 1/9.
This is what math does to people.
Makes us really good with jokes.
Okay, where's 0, 1 at?
That's the joke that Pinky just made.
Up 1. Where's 1, 3 at?
Right 1 up 3.
Where's 2, 9 at?
Right 2 up.
Way up there. So it's
Just
starting.
kind of doubled over
It's
time.
starting to explode. This is what they call exponential growth. Like it starts out tiny and then all of a sudden, boom. That's like if you put a bacteria in sugar water, this is what happens to their population. Boom, like that.
What? Put what in sugar?
If you put a bacteria in sugar water,
To grow faster.
because
Sugar.
I know science.
Science and math experts.
That's what their population does.
Well, the bigger close.
Because they reproduce and those reproduce and those reproduce.
Reuse.
It goes up faster and faster. That's what happens. All right.
What is this? What?
I think I'm gonna do something a little bit weird, and I'm gonna do number 6 because 5 and 6 kind of go together. So I want to just look at that.
Thank you.
And 7 and 8 kind of go together.
So we're gonna do those two together too?
9 and 10 go together. No, I think I'll just do 5 and 6 and maybe skip 7 or
I
something.
mean, this should be just an easy, relaxed day. Where we all do it
We're only
together.
going to 12. That's
And
not
we
that
all
much.
do the right problem. Now we're gonna have to
Okay.
go over here.
Yeah. Y equals 1/3 px. There we go. Table. Same. Did they use the same x and y x's on all these? Well, once you get to 11, 7. They start using -3 also.
They always use.
Okay. Ignore the negative for a second. What is 1/3 squared?
2/9. Wait, 1/9.
1/9.
Yes.
Okay, but what if it's to the -2? 9.
9.
Instead of 1/9, it becomes 9. Alright. Okay, what's 1/3 to the -1?
3.
3.
Yes. Didn't think I
Okay,
did that.
what's 1/3 to the 0? What's 1/3 to the 1? What's 1/3 squared? We already said that one. 1/9. Alright, you guys see how this one and the last problem are related? It's all backwards.
Oh, that's weird.
Okay, so what's the graph gonna look like?
Can we just draw it on the same
So-
graph but in reverse?
Yeah, it's in reverse. So we're going up to 9. 1, 2, 3, 4, 5, 6, 9.
Oh, can't draw a straight line. Save me.
You just trace the. No. He was.
I still can't draw a straight line.
Alright. So -2, 9 should be way up there. -1, 3. 0, 1. 1, 1/3. 1, 1/9.
Wait,
Whoa.
I had to draw. No,
You don't need me to do this. Just do it yourself.
But it's so easy to just look at the board.
Just do it yourself. It'll be even easier.
No.
You don't have to look up that way.
No. Okay.
So it'll forever be getting closer and closer. My graph is not pretty, but it should be forever and forever getting closer to 0 without ever getting there. Closer and closer and closer. Never makes it. Kind of like the end of school day.
Yes.
So mean. So now we're doing 7?
That was awful.
Huh?
That was worse than Will's joke. Hey.
You should be thankful. I almost made a joke about you making baskets.
Yikes. Wow. Yikes.
Whoa. Huge yikes.
I don't know what I'm doing.
Do seven.
All right, I'll do 7 and then I'll stop, I guess.
What?
Or
What did he say?
I'll do 7 and 9 and then stop. We'll do that.
What did he say?
What about 11?
You know.
What wasn't the arrangement?
7.
All right, 7.
Leon, that wasn't the arrangement.
So on this one, we are going from -3 to 3. That's the big difference. 2/3. It's a long table.
I can tell you all of them.
Okay,
They're out down.
let's do
Okay,
this.
what is, so we're cubing it, negative cube. What is 2 times 2 times 2?
8.
What's 3 times 3 times 3?
27.
And if it's a negative exponent,
27 over 8.
27/8.
Oh, does that mean it just goes to 8?
Okay, what if we square it? What's 2 squared?
4.
What's 3 squared?
9. 9 over 4.
9 over 4. Negative exponent flips it upside down. The smart board has not been behaving.
Does that mean 3 over 2?
Okay, number 1, yeah, -1 is 3 over 2. To the 0,
1.
to the first power,
3 over 3.
stays the same. Squared,
4 to the 9. I mean 4 over 9.
yeah, 2 squared 4, 3 squared 9. Cubed. We kind of did all this right here, right?
8 over
8 over
27.
8 over 27.
You guys are so smart.
Okay, now how do I graph that? Well, you change it to a mixed number or a decimal. Change it to a decimal, you divide 27 by 8. Change it to a mixed number, you kind of do the same thing. How many times 8 go into 27? 3 times 8 is 24, so the remainder is 3. So this one, first one is actually 3 3/8. And then let's keep going. 2 1/4. You plug it in your calculator, it'd be 2.25, right? And then 3, 1.5. So this one only goes up to 3 3/8, so you don't have to make a huge
What
graph.
about the bottoms?
The bottom is a fraction, but it's still bigger than 0.
Ah,
Proper fraction.
we need a lot of room for those.
1, 2, 3, 4. Really, you only need to go up to 4,
Why? Because it's 8 over 27.
because 3 3/8 is less than 4.
But what about the 8 27?
That's a little bit bigger than 0. It's about 0.3 roughly,
Ah,
about less than 1/3.
I get it now. No.
3 3/8 would be just short of 3.5. My graph is kind of tipped over. I can cheat and fix that.
A little bit less than 3.5?
Ooh.
I don't think I did anything.
That's so much.
Yeah, 3/8 is 3 is less than half of 8, right? So 3 3/8 is a little less than half. Halfway to 4. My graph's not very pretty. There. Okay, -2, 2 1/4. -2, 2 1/4. Should be a little bit higher than that. -1, 1.5. 0, 1. What point have the first 3 problems had in common? 0, 1. Because anything to the 0 is 1, right? That's going to change on number 9 because we're not just doing 3 to the x, we're doing 3 to the x times 2, so it's going to be a little bit different. let's see, 1 2/3, right about there.
2 and 9.
Whoops,
What?
what's not doing
What
that?
did you say?
I forget to write the whole thing. It's 4/9, right?
Yeah.
2 and 4/9. 4 is a little bit less than half of 9, so close to half. And then 3, 8 27ths. 8's a little bit less than 1/3, so it's pretty low. Obviously, you can kind of see the pattern.
What about the?
Kind of missed. I got an excuse. This whiteboard is not quite.
No excuses was for 4 and 9. Did you work late?
What is that dot right there? Is that number 9? On the.
That dot?
No, the other one.
-2, 2. It was supposed to be 4 9s, not 9 right there. No. This is 2/3.
Mr. Jordan, is number 8 the same thing as 7 except in reverse?
I think all of these are pretty much the same.
Well,
So if you solve one of them, you solve the other.
actually 11 and 12 are not paired up, but the rest of them are.
Alright.
Sweet, so I could just go off with 7 and just do it in reverse.
Yeah, you still need to write the
Oh, still
table,
write the graph.
but you can you can use the answers to help
Okay.
you out, yeah.
I think I figured out 9.
Okay, I think I'm gonna, well, okay, 9, fine. I'll do 9. One more.
Please.
You don't need my help.
I do
Yes, I
need
do.
your help.
What are you talking about?
You're a math wizard.
Too long.
Okay, y equals 2 times 3 to the x. The x values, we're going from -2 to 2 on this one again. It's a little bit smaller. What is
1 9.
3 squared would be 9, but 3 to the -2 would be 1 9. What is 2 times 1 9? 2 ninths.
2 9s.
2 9?
What's 3 to the -1?
1 over
1 over 3 times 2.
2 over
What do you guys think the times 2 is doing to this graph?
stuff.
And then twice as big.
It's making it twice as tall as it would have been otherwise. So it should look like number 5, but be twice as tall. So remember number 5 went up to 9? Okay.
18.
18. So you might want to count by 2s or something, or you can just make a really tall graph. 3 to the 0,
0. And with 1?
1 times 2. 3 to the 1
3.
times 2.
6.
3 to the 2
9.
times 2.
18.
Okay, all those numbers are twice the numbers from numbers 5.
Yeah.
How do you count by fractions?
How did
on a graph?
18 tall? You change it to a decimal. You can count by 2.
Okay, you can count by 2s. If you are going to count by 2s, you need to put a little 2 there.
To show that you're doing
2, 4, 6, 8, 10, 12, 14.
Look at my graph up there. 6, 8, 2, 4, 6, 8, 10, 20, 30.
So, if I'm counting by 2s on my y-axis, it's going to actually make the graph look shorter than it actually is, which is fine. But
Turning out bad everybody.
okay,
Not bad
-2, 2 ninths.
It's a little less.
It's like almost, it's over 20% of the way, so I don't know. It's just not very tall.
Big yikes.
-1, 2/3, so you go 2 out of 3 of the way up to 1.
This thing's
0, 2. Oh, shoot, I forgot. I'm counting by 2s on the way
yeah, I
up.
was like, wait a minute.
So I actually should have been a lot flatter than I was.
Wait a minute. Have I seen
Okay, let me try again. So 2/9, if I'm counting by twos, it should look like 1/9 actually, which, whoops,
What?
this is becoming a mess. It should be right off the line. Okay, and then 2/3 should look like 1/3 since I'm counting by twos. This is a mess. Can't fix it. And then 0, 2, so 2 remember was our first mark if you're doing the same way I am. If you're counting to 18, you don't have to worry about that. So where's 1, 6 at?
3 up.
Okay, 3 marks up.
I went all the way to 8.
Where is 218? Well, that's the top of my graph. 218. So when you do it like that, it should make it look like number 1
Is number 9?
because we counted by twos.
Does number 9 look like this one? It does.
That was number 9.
And number 10. Wait, that was number 9.
Number 10 is going to be backwards
Dang.
from number 9.
Now I'm annoyed.
Like 5 and 6 are backwards, 7 and 8 are backwards, 9 and 10 are backwards.
7 and 8 are backwards.
You
2/3 and 3/2 is gonna flip around from left to right. All right, give it a go.